Okay. So, welcome to Orlando Python, everyone. We normally don't get a large crowd, but whenever we have anything that is beginner focused, we definitely get a lot of people coming out. It's so this is a part one of 3 beginner series because as often as a lot of these meetup groups like to have really cool features, uh, sometimes it really does take places like the Iron Yard to help people actually get into code. Because the meetups, while we like to be as beginner friendly as possible, we don't always do a good job of it. So, with Florida PyCon rolling around on October 7th, which I am also organizing, head organizer of that, sounded like a good time to have a beginner series. We haven't had a beginner series in Python in at least a year. I think Sarah Holderness was the last one to give one, and that was back before we were recording all of our talks. So, coming in, well, if you had, go ahead.
Can you tell us broadly and briefly, possible, what can you do with Python?
What can't you do with Python? So, Python is one of those really nice languages where it doesn't really have a niche. You have JavaScript, which is really web, and people try to shoehorn it. There's microcontrollers, embedded hardware that you can program with JavaScript, but it really is home on the web. You have programming languages like Swift, which, granted, Swift was primarily developed by Apple, and it's used for mobile programming, and there is a large concerted effort to make it work more on web servers and not for iOS applications. But a lovely thing about Python is that you can use Python in just about every platform, every kind of, pretty much any kind of job. And because Python is both incredibly easy to learn, but also incredibly powerful, you can have major programs running it, and also people who just want to automate some of their things at work who are not programmers and get a lot out of it. Python, depending on the company, the metric, the organization, typically is always in the top 10 most popular programming languages, and the IEEE Foundation organization actually has it as the most popular programming language currently, which is always nice. It has a good home for web backends, embedded hardware, because of things like the Raspberry Pi and CircuitPython. It has a huge influence and use in the data science community, machine learning, and really just anywhere that you could put it. If you have a Mac, Python comes. If you have a Mac or most Linux distributions, it comes with Python. And even Microsoft is being more Python centric as of late, which is really nice to see.
Can you put a Python in an Arduino? I am aware that you can.
It depends. There's a library or a language subset called CircuitPython that just went 1.0. I think one of the core developers actually works at Adafruit, and they have a handful of boards there that some of them you program and then it compiles down to bytecode, which then gets run as though it were C code. But then you also have boards that are specifically designed to run Python and have Python files on them, which is really cool.
So can you use Python also to make queries over MySQL or
Yep.
any other data warehouse?
Yeah, in fact, one of the really nice things about Python, as far as SQL libraries go, is that it loosely enforces all SQL libraries to have the same schema, the same basic API, so that you can switch your Postgres, MySQL. You can start with SQLite and just change, and you don't have to change any of your code, which is really nice.
How about NoSQL databases or data warehouses?
There's MongoDB's native language, the most popular implementation, is actually in Python, and you have, but those are for things like MySQL, DocumentDB, DynamoDB, depending on your preferred platform. They all have their own independent libraries, but one of the really nice things about Python is that you can take any JSON object, which is essentially a document for NoSQL databases, and it is legitimate Python code with a few minor exceptions. You just change null to none and then capitalize Boolean values, and it is valid Python, which is pretty cool.
Thank you.
So, there's a spot back here. Just want to grab a chair and bring it in. We also have other tables out there. We can figure out how to squeeze people in. Cool.
Yeah.
Okay. So, anyone want to dive right in, or any more questions before we start? Let's dive right in. So, if you are on a Mac or working on a Linux system, you can simply just open up the terminal. It's their terminal. I have it in my dock, but you can go to Applications and just type term, and it will be one of the only things that comes up. If you've never worked with the terminal before, it's not scary. It can do a lot of damage to your computer, but it's not scary.
It's just text.
It's just text. If you are on Windows and you haven't used PowerShell yet, I highly recommend using PowerShell over the command prompt. Python works much better, it looks much better in PowerShell.
Is that preferred over using the Python shell itself?
If you want to open up the Python shell itself, which if you installed it on Windows directly from Python, the python.org, absolutely, it's the same thing, just with some more Python-centric text formatting.
If we don't already have Python 3 and Python 2, should I go ahead and download it, or should it take too long?
I don't think, well, I would recommend go ahead and download Python 3. It won't take too long. I don't think we'll get to anything today that will be breaking in Python 2, but certainly when we get to classes, you'll definitely want Python 3. All right. So with your terminal or PowerShell open, if you had to install Python 3, if you already had Python 2 on your computer and you had to install Python 3, you will want to type in Python 3. Let me just give you a quick example. Most times, when you type in Python just by itself, it will actually come up with, actually I don't even have Python 2 mapped on there. The first thing that you see on the top of our interactive prompt is the Python version number. If you see Python 2.7 I think they're up to 12 now, try typing in Python 3. And if you have Python 3 installed at all, this will force it to use Python 3. So as long as everyone can, either in the Python interactive shell, which is part of Python idle, for some background reference, Python is the only language that has an idle as opposed to an IDE, and that's because Python is named after Monty Python. The original documentation has a lot of Monty Python jokes in it. Some of them still survive to this day, and the programming environment, the coding environment that comes with your main download of Python has an idle because Eric idle instead of IDE.
So if there's a multi-Python, if there's a multi-Anaconda as well?
Well, Anaconda is pretty nice. Anaconda gives you the option to download a 2 or 3 centric version, but once Anaconda is already installed, you can create virtual environments and change the Python version that runs inside of that virtual environment. So you can grab, if you have Python 2 and 3 installed on your computer, but you only downloaded Anaconda for Python 3, you can create a new source create, or conda create my environment, source activate my environment, and then change the Python language back to 2. Some fun stuff.
One last question.
Okay.
For those of us who decide that we do like to use the IDE, do you have any preferences? I have PyScripter and PyCharm, but are there any?
We'll get to, as long as you can open up a terminal within your IDE, doesn't matter. We're working with, we're just going to play around with the interactive prompt a little bit. We'll get to actual Python files a little later. But some basics on, a very basic point on Python. Python is a non-compiled language. It gets down to bytecode when it's running using something called a just-in-time compiler. But one of the advantages of this is that we can use something like an interactive prompt to play around with basic attributes of the language itself, basic functionality, without having to write files. If you've done anything with C, Java, Swift, Objective-C, if you want to test out a language feature, you need to write its own little main function to test some code in. You don't need to do that with Python. So let's jump right in. If you've ever coded before, you know what's coming. If you haven't, hello world. So in Python, we have our print statement. Strings, you can either use double quotes or single quotes. I prefer single quotes. That's just me. And our basic print statement.
Is there a difference between single and double quotes?
Not in Python.
I guess if you are using double quotes, then you can write let's.
It looks a little, to me it looks a little cleaner, but functionally there is no difference in Python between using single or double quotes.
Meaning that you can write single quotes.
Oh yes, absolutely. So one reason why you might want to just go fluidly back and forth between two. I have my favorite. I like using single quotes, but if I wanted to do something that involved an apostrophe, I can't do. It's a great day, and surrounded in single quotes, because that gets me an error because it thinks my string ended at it. So we can wrap it in double quotes, and it will work just fine. Similarly, if you have a sentence that has double quotes in it, like you want to be a little obvious that it wasn't a great day, but there's still it's in there, we can do that. So how do we solve that problem? In Python, like a lot of other languages, and this is actually where I prefer to use double quotes for all of these. If you have 3 single or double quotes in a row, there we go. If you have 3 single or double quotes in a row, it will just wait until you have 3 more single or double quotes in a row. That allows you to do mixed basic typing. It also allows you to do multi-line strings, which, depending on your file, makes it look nicer. It allows us to have more readable doc strings. We'll get to that eventually. And in case you've never seen backslash notation before, \n is encoded for new line, \t is for tabs.
Escape characters.
Escape characters, thank you. So that's printing strings. Let's get into the basic types in Python. Now, one of the nice things about Python is that everything in Python is an object. Everything is a class. There are a lot of languages where that's not necessarily the case, but that means that we, at a very basic level, all the different types that we have some common attributes. But let's get right into it. So we can actually inspect our different types. This is a built-in function that displays the type of whatever you pass into it. So type of just the number 1 is an int. It's short for integer, and is anything that is 0, 1, 2, 3, 4, minus 1, minus 2, anything that does not have a decimal point in it. Things that do have a decimal point in it, like 1.5, are floats by default. Not to get too into it, but there are some problems with floats when you are dealing with a lot of numbers. There's other classes to handle that, but most of the time you just need, when you're working with numbers, you'll just have ints and floats. We've already looked at strings, but just to give you an example, this is an empty string. It is still a string. And the last of our, well, we have two more basic types. We have a none type, which is just none. It means that we don't know what this is. You can override things with it later. It's just an encoding. It's a class that represents there's no information here. And lastly, we have a Boolean type. A Boolean can only have two states, true or false. Unlike a lot of other languages, Python capitalizes true and false. So that might trip you up a couple of times. And these are the most basic types that you'll run into that are not collections. We'll touch on those in just a little bit. Any questions so far?
So is none similar to null in other languages?
Yes, exactly. Yeah, Python uses none. A lot of other languages use null. It's exactly the same concept. And when you are converting in and out of JSON, it converts null to none when you import in Python, and vice versa. Any more?
Why does none and true have to be capitalized?
That's just the way. That's just how it is. That's the coding convention since, I imagine, Python 1.0. So before, yeah, basic types. Let's go over. Let's introduce our two primary collections. Now, a collection is anything that contains other objects, other classes. And the two primary collections that we work with in Python are lists and dictionaries. In other languages, you might hear lists as arrays. Same concept, they contain things. And dictionaries, in JavaScript, they're called objects, hence JavaScript object notation, JSON. Other languages call them associative arrays. It's just a way to map key and value pairs, and we'll get into that in a second. Let's talk about lists first because they're pretty easy to understand. So, in Python, there are many ways that you can instantiate things. Python is what we call a duck language. If you think it will work, it probably does. As opposed to a lot of other languages, Ruby, where there's only the one right way to do it. Granted, there's also something in Python called Pythonic, but we can get to that later. So for a list, this creates an empty list, and empty brackets create empty lists. As looking pretty similar to other languages so far if you've ever worked in other languages. And lists can contain things that are comma separated. You don't have to include the space, but it is good formatting. So we created a list that has 4 integers in it. Now if you're coming from other languages that are not JavaScript, I'm about to blow your mind because Python is not type safe. We can put whatever we want into lists. A lot of other languages, you have to declare when you create a list that this is a list of integers, and if I put a none value or a float into a list of ints, it complains. That's because those languages are compiled and have a lot of optimizations. Python has no such thing, and therefore it can be not type safe.
What's the difference between known and not put an anything?
So
You have in the first line you have declared a list of 4 elements. In the second line you're also declaring a list of 4 elements, but the last one is non-existent. What is the difference between the first and the
so the difference. Well, the difference. Well, it's a programming concept. So none does not necessarily mean the absence of everything. It just means the absence of information. So if we this list here, this 1, 2, 3, none, still is a list that has 4 items in it. However, we don't. There technically is no value for the last item in the list.
So that element exists, yes, has no value in it.
Yes. If you want to think about this like a row in a database table, it's null. And if you were to export that data or read in that data, you would read in 1, 2, 3, none, which just means that this column has no information in it.
Can you have puts 1, 2, 3, Charlie?
1, 2, 3, Charlie.
Meaning the last one is a character, a string, and not.
Yeah.
Or maybe 1, 2, 3, C. Okay, so.
Same thing. Not type safe at all. You can put whatever you want to into these things as long as it makes sense to you.
You can do a list within this, right?
You can indeed. So this is currently what we call a one-dimensional list. A two-dimensional list is a list that has other lists in it. So if you want to think about, you could think of this as a list of coordinate pairs, or it could be anything. You can put, I think you can put anything in a list, because everything in Python is an object. Classes are objects. Basic types are objects. Functions can be treated as objects. So you can put anything in a list.
When typing in straight Python, is it white space sensitive at all?
It is indeed. We'll get. I can.
Is,
well, no, actually, that's a good segue. So.
Spaces.
The eternal debate over tabs versus spaces. Yeah, so Python is white space sensitive, and we'll get to that when in a little bit when we start looking at if statements and for loops. So that's going to be fun.
Okay, so let's just pretend for a minute that I'm a beginner.
Mm-hmm.
You talk about objects. What is the significance of something being an object?
Significance of something being an object is that it because everything in Python is an object, which means that it is a class. It contains certain attributes beyond the value that you see here. So you can think of this is an integer that has a value of 1. But if I use this is the dir function in Python. It is a global function that will list all attributes of a thing.
Okay.
So if I just put in 1, that's a whole lot of thing. Anything that has double underscores on the front and back is what we call a dunder method. It is a Python special method. Things like that underscore underscore add underscore underscore. That is the actual function that gets called when we do addition. So when we say that something is an object, it means that it is a class, contains methods beyond just the value that you see.
So all those things apply to that.
Exactly. We can do that with other objects as well. So that's an int. This is a float. It looks very similar, but it's not entirely similar. Just as an example, float does not have a public float does not have a function called denominator.
You did a list with 3 lists in it, something like that.
Mhm.
How would you print, say, the second?
So, okay, I'll show you exactly how. So we have, let's do a lot with lists here. So I have my list. For the sake of introducing a new concept, let's talk about variables. Variables are a way that we can store values and give them aliases that make it easier for us to work with data, work with their values. So here I am assigning a value of a list containing the integers 1, 2, 3, 4 to a variable called x. When you get into programming, you almost never will call any variable x. You want to be a little more descriptive, like int list, whatever makes sense to you, and more importantly, other people who have to read your code. But for simplicity, I can just call it x for now. So if we just assigned a value to x, I can call up x, and it is equivalent to the value that we gave it. And just for reference, I can also go ahead and print x. It's the same thing here in the Python interactive prompt.
I just typed in list equals bracket. But isn't list, why did it let me do that? Isn't list a keyword?
Yes, it is.
I just wanted to see what would happen. I expected it to complain.
Python allows you to overwrite everything. So if you say list equals 1, 2, 3, 4,
That's what I did.
if I type in list, I get that. I can still make more lists, but I can't say x equals list 1, 2, 3. That looks a little disgusting. 4. Because list is now a variable name and not a built-in method.
So how can you fix it and get you a list back?
So when you're in the interactive prompt, all you have to do is call quit, which is a function, load it back up. Your history is all still there. I'm just pressing the up and down buttons right now. And if we go back to list 1, 2, 3, 4, takes at most one argument. It's back.
Do some of the IDEs, like Anaconda, for example, give you a warning if you do something stupid like that?
If you have any kind of linting installed on your text editor or your IDE, most of them will give you a warning that you're overwriting a built-in method. Yeah. So that was variable. How to access things inside of a list. So again, we have, let me get my x back. There's my x. So in Python, we have, to get the values inside of our list, we have something called subscripting, similar to other languages. So we say, here's my list, or we can get to the technical details later, but you will see this notation come up quite a lot in Python because there's something that, the concept of an iterable, of which a list is one, which means we can subscript it. And for Python, that just means we give it bracket, we give it a variable or just something that evaluates to a list. And in brackets, we can supply indexes. Python is a software programming-oriented language, so indexes start at 0, not 1. That trips up a lot of beginners. You won't forget it.
But all languages do that, right? You say software.
Not all. So a lot of languages that were designed for other professions initially, sometimes they will start at 1. R is a really big language that starts at 1. Yeah. I think MATLAB also starts at 1. Now, my divider was it designed for mathematicians or programmers?
Okay,
Programmers start at 0.
okay.
So, if we take it and we give it an empty list, it doesn't know what to do with that. We can give it an index and it will return stuff there. You know, for the sake of example, all these are fine. Notice how notice our first index is at 0, and even though we have a list of length 4, our last index is at index 3. The last item is at index 3. You can do, I'm about to introduce another built-in function. It's called len, which will give you the length of something. So if I do length of x, it's 4. There are 4 items in our list. -1, that's the index of our last one. So if we wanted to, we could do, we could use this to just say, give me the last object that's in my list. That gives us 4. However, there is this thing, we can actually make this really simple, because notice that starting from the beginning, your first index is at 0 and it goes positive. Python has this really nifty feature where if we give it negative numbers, it starts from the end of our list. So index of -1 is the last item, index of -2 is the second to last item, and so on.
Forever, like if I gave it -31, would it keep wrapping around?
It will also error on the other side. So just for example, -4 is our first item. It's the fourth from the end of a list of size 4. If I give it 5, we get an index out of range error. Same thing if we do index of 4, index out of range. So it's pretty smart like that. Another little thing, if we wanted to get more than one item, let's say I wanted to get the first two items. In Python, we put a colon inside, and if we leave the first one empty, it means start at the beginning and go up to but not including the object at index 2, and that will return a list of 1 and 2.
I'm confused.
Go ahead.
If you're listing X column 2, it means that you're listing elements 0, 1, and 2.
I could change the values inside of it if you want, to make it a little clearer.
No, that's not what I'm asking. I mean, you're not starting from 0, you're starting from, actually,
Yeah, this is functionally equivalent to doing that.
yeah, those are 3 elements.
Well, this when we do this multiple element, it is up to but not including.
Oh, okay.
Yeah, so if I just wanted the first 1 and want to do it like that, it is include 0 up to but not including at index 1, 2, and so on. Same thing if I go out of bounds. Actually, this is kind of funny. It will go. I guess it's a little smart. I was actually expecting it to error. Learn something new every day. So what do you think is going to happen if we do this?
Up to the last element,
Starting at?
starting at 2. Up to
So
the
that will
last
get-
element minus 1.
Yep. So that gives us 3 and 4. You will never ever see this, but actually, any thoughts on what this will give us?
It will give you,
It will give us
Last
just
ones.
3. Because it's up to but not including index at the last element. So kind of cool.
So in Python, it never includes that number, it's up to.
Yes, up to and not including. I think other languages like Swift and maybe JavaScript do up to and including. I know Swift does. I'm not sure about JavaScript. One other thing that we can do, since we're on a roll here, we can say let's see. Let's start at that one and go up to but not including the last element, which is also functionally equivalent to that. So that gets us 1, 2, 3. But we want to, we can also supply one more argument, which is a step. So what do you think this will return?
The whole array.
It's going to repeat.
But the last one is a step.
Oh, so
Oh, it's gonna
Just
0
every
and
other.
2.
It's going to be every other. So this one is going to return 1 and 3. We can actually, this will return the same thing, but if we think of the colon as there still being values, empty values between those colons, we can do this, and it functionally returns the same thing, but if we gave it a larger list, it would only just include every even number. If we did start at index 1 with this, it will return everything at an even, or I guess technically an odd index, but an even position. Indexing, always fun. And just like we've seen before, what do you think is going to happen if we give it a negative number?
It's gonna jump backwards.
Starts from the end. In fact, if we just give this -1, it returns our list reversed. There are other things that we can do. For example, this is another built-in function that reverses a copy of something that it is given. And actually, this is where Python 3 and Python 2 are a little different. Python 3 is actually more efficient because they added a couple new classes for handling certain things like this. So if we wanted to get our thing back, there we go. It returns a copy of our list. Or if we do this, notice that we have variable, period, name of a function, and then empty parentheses. We are calling a function that is part of the array or the list class. And this actually does what's called an in-place change, in-place sort, in-place reverse. So it doesn't return anything. And if we go back to our x, we've reversed our list. Can do it again.
What happens if you put y equal x colon minus 1? Y.
So we just took what we did before where we used indexing to reverse our list, and we have set it as the value of a new variable.
So you have there an algorithm that can reverse the list.
Yep.
This has an instruction.
So just to print out both, you can see that we took the value, applied it to y. They both exist at the same time, functionally independent. We can change values in either one, won't affect the other, even though they started with the same thing.
Why is reverse call method?
It's the same thing.
I don't know. Internally, they call the same C function. Just one does it in place and the other returns a copy.
Could it be maybe to make a little difference between regular languages and object-oriented languages? Method is more object-oriented.
So Python is definitely an object-oriented language. It can be used in a functional way. So object-oriented languages, we work with objects, whereas we work with objects, and that has its own benefits, it has its own problems. Things like functional languages don't have classes, because classes are inherently an object-oriented thing, and you're supposed to. I'm not really the best way to answer that question, to be honest.
Also, many functions are already part of the language. So a language has some library functions that are integrated to the language itself.
Mm-hmm.
Meanwhile, the methods you have to build it. Or there is the case in which there's methods that come with Python. I don't think
So, well, Python, as opposed to a lot of other languages, especially languages like C, uh, you have a lot of functionality given to you in the standard library, or not even the standard library, just basic Python. And you have other things like URL lib. You have more advanced collections that are all part of a standard Python install, but you don't get right off the bat.
let me ask you one last question. Functions usually return one value, and we can substitute in an operation the whole value by just calling the function. Meanwhile, I understand that you can, in a method, you can return many values.
Yes, yeah, we'll get to that when we get to functions, but Python allows you to return a tuple because, and the tuple can contain mixed values. So we'll get to that as one of the advantages of Python not being a type-safe language.
To the screen.
Yep.
What, I don't know if you said it or not. What do you call a double colon when you
So there's it's subscripting. There's no name for a double colon.
No, not double colon. Like when you doing that, isn't it called like splitting or slicing?
So other languages, I know JavaScript calls it this, but yeah, it's considered a slice.
Okay.
I'll pull this up real quickly. Python has some excellent documentation. Docs.python.org. This is just to show you all of the different built-in functions that come with Python. Without having to import any other libraries, you have all of these built-in functions available to you. There's some that we've already seen before. Here's dir. All of the basic types also have their own calls as well. str, we already saw list. I quickly pulled up len for you guys. Definitely get familiar with these, although you won't always, there are a handful of these that you won't use very often, even though they are available to you. Some of these you will definitely use a lot. Min, max, casting is actually where you would use something like this.
I had a question. So a few lines up, you have list reverse x.
Mm-hmm.
And so I tried, on my own, replacing list with square brackets. I assumed that would do the same thing, but it didn't.
No, and yeah, you're absolutely right. So in Python 3, reversed doesn't return a list. It returns an iterator, not an iterator. It returns a generator, which is not a list itself. It just knows that here I have some values, and I will spit them up to whatever code wants them when they ask for it. So by calling it by putting it in the list function, we're turning that into a list. As opposed to if we just did, if we just put brackets around that, we just get a list with that object in it. It's not actually turning reversed x into a list.
So there's some subtle differences between the list function and the brackets notation.
Yes, there are different lists. You tend to use the brackets when you're actually just creating a basic list. You use the functions when you are casting other objects into that type. And I'll actually show you a quick example. So if we have an integer, so we have an integer. We can turn that into a string by casting it to a string. It is now type string, and just show you guys what that looks like. A string with 1 in it. We can go the other way as well. So just to hammer it away. If you know that you can convert types, int, not int, it will likely work for you. We can also cast this to a float. Notice how a float will always be signified by it having a decimal point in it somewhere.
What happens if you put the float 100?
Hmm?
What happens if you put float 100?
Float 100?
Yeah.
As in just coming from a string? It's just 100.
She was trying to pull her history, and she had to Python thing.
Yeah, I was just trying to do what you're doing, where sometimes you can call
Oh.
the commands you've typed in like that. Yeah,
Going up and down. Are you in a terminal or are you in the idle?
She's so glad about
Yeah.
I don't. It's been so long since I've used it. I don't. It should. I don't know why it wouldn't be doing it.
it. She just goes up on the street.
That might be something in preferences or options that you could take a look at. Let's see. Oh, so we talked a little bit about working with strings and subscripting. Oh, there's our error. We have our same. We have our list here. X list of 1, 2, 3, 4. We can just to show that we can subscript with anything that is a list of something. What do you think would happen if we do our hello world here? And I'm just going to put this as my string hello world. And string again. We have hello world. What do you think will happen if I do something like that? It reverses my string. So, fun little thing. Python is, in more ways than one, a wrapper around the C language. In C, strings there's no such thing as a string, but there is such a thing as a list of characters. In Python, a string is merely a list of characters. So we can treat it as such. We can treat it as though it is a list of individual characters. So if I just want to get the hello, I know hello is of length 5, so we can go from beginning up to but not including at index 5, and we get hello out of it. Single subscripting as well. There's a space in between hello, comma, and world exclamation point. We can also pass it into our if we just do my string dot reverse. Oh, strings don't have that method. You know how we can probably still get it by doing this. So let's actually cast it back into a string. I always learn new things when I go back to basics like this. Reversed object at, because it casts into. Let's see if we can take our reversed, cast it to a list, which then casts it to a string. I'm trying my best. But anyway, that worked. That's kind of cool. We can treat strings as lists of characters, or lists of one character long strings. Before we go, let's go into dictionaries now. So dictionaries in other languages are called associative arrays. In JavaScript, they're called objects. Not to be confused by the Python term, because Python actually does have an object. It is the base class of everything. So don't get that confused. But a dictionary is declared using curly braces. Because Python doesn't use curly braces for loops, it uses white space, we can use curly braces for dictionaries. And the syntax for that is we give it a key, colon, and I'll just give it an untype here. So this is a dictionary that has a key value of 1, and the well, has a key of 1 whose value is none. I could also, just to show off the not so type safe nature of Python, I can also say a key value of A is equal to 1.1234. That is allowed. With dictionaries, we subscript them. Well, we use the brackets. Or let me actually assign this to a variable. I'm just going to say my dictionary. We do subscripting like we normally do. However, notice it does not take indexes. There is no key in our dictionary for 0. There is, however, a key for 1, which is none. So for the sake of, well, let's see if we can actually print my dict. There's none. And there's also a key value for A. Typically, when you see dictionaries, you'll have the keys will almost always be strings, and the values can be whatever you want them to be. Just because you can mix key values, different key types in there, doesn't mean you should. It will complicate your life later down the line. But to show you an example of where this might actually be used, let's go. I'm going to go ahead and do some nice multi-line printing here. So let's say that Mike got a score of 50 on a test. Charlie got a score of 80 on a test. And Andrew got a score of 85 on a test. And I'm laughing on the inside because this is my family. So actually, let me go ahead and apply that to a variable. Let's call them scores. And I'm just going to quickly use my up arrow to backfill that. So print out scores. There we go. So we can do scores. I want to know how Andrew did. And he had a score of 85. Very simple. Instead of dictionaries, instead of taking indexes, they take key values. And those key values can be whatever they want. Typically, they will be strings. You'll most often find them being strings when you come across other people's code.
Can you put a score 80?
This score 80. Let me show you how you can add that. So I didn't go adding I haven't really done adding or removing anything to any of these objects yet. So we already have scores. If I wanted to add, I can't spell anymore, a new person to it, we can give it a new or existing key. And let's say Sadie got a perfect 100 on that. If I go ahead and examine my scores function again, notice we've added Sadie into our dictionary.
Awesome. How did you use the up arrow to assign scores to that dictionary?
When I was just doing the multi-line, rather than going ahead and typing everything out, I just went up to the previous thing. Whenever you, in Python, at least in the interpreter, whenever you see those triple dots, it means that it hasn't evaluated whatever you've typed yet. And in this case, in this case, it was waiting until I had closed my array, and I could just use the up arrow to go back to what I had already typed to fill it back in.
So, well, after you created the dictionary the first time, it didn't have a name.
Oh,
but
yeah.
Then you wanted to assign it the name scores.
Yeah, so I went back and put scores in front of it, and then went back up to click enter, so I didn't have to type out these lines again.
And then executed the whole command.
Yeah, and then when I got back down to the closing curly brace, it executed because it found what it was looking for to close that bit of code. It will look nicer when we get to working with files. Everyone in here will make a Python file and run it before we're done. And we are halfway through with what time we have, just for reference.
Same type of error message, whenever I try to write the scores.
Commas, there you go. Commas will get you, always. So, let me double check my built-ins. Well, it has bell ladder. So that's adding something. Let me, actually, let's take a look at some attributes of this. Let's say we wanted to just get our keys out. In Python 3, all we do is scores.keys, and it is a function. It is a class function, which returns dict keys, which is an iterator type, but it returns all the keys in order, which is Python 3. If you're doing Python 2, you do iter keys, but that's just for, you won't need to worry about that if you're running Python 3. And if we want the values, we just do values, and out pop our values. Now, why in the world would you want to pull out keys or values? If you're when you want to do a for loop.
Real quick question, going back. Is it okay, can you also use a pen function in a situation like this or no?
You can use append. Actually, you cannot use append for dictionaries.
Okay.
You can for lists. It's really a list thing.
Okay.
So just quickly, we have our list here. This actually is a great segue. So if we just wanted to add things to our list, we can append another 1. That just adds it to the end. So we have 1 again. Now this isn't going to assign it, but we can also say I want to add on the values from another list. But notice that we didn't actually overwrite anything with X. I'm about to blow some people's minds, unless you come from the C world, I think. Python allows you to do such a thing as a plus equals operator, which means take whatever the value of X is, add this other thing to it, and set it as its value. So if I just run that and check my X again, with very little code, I just added 2 things together. It is functionally equivalent to this. Just some nice shorthand.
So when working with lists, you're not actually doing math on the object, you're instead adding it to an object.
Yes.
Can you also subtract from the object?
It depends. So there is such a thing as minus equals. There's also a times equals and a divided equals. Couple of other things in there. As for, actually, let me see. So let's say we have 1, 2, 3, and now I want to minus a list that has 3 in it. There is no minus sign for a list. However, there are a couple of different ways that we can remove things from lists. If you want to do it by index, you can always do x.pop. By default, it pops at the end, so whatever is last on the list. So if I run x.pop, it returns the item that was removed from your list, and if we check the list again, our last item has been removed. If we want to remove from the front of the list, we can do 0, or any index that we give it.
Thank you.
The other thing that we can do, and this might not work right off the bat, so bear with me. There is such a thing as del in Python. It is a special keyword. It is an alias for a function called del attr sometimes, or del value. But we can do, well, I'm not entirely sure. Let's see. Okay, so del at index 1. If we want to remove by value, so let's say I have this list of 1, 3, 4, and 1. Let's see, we can do remove 1, and I think just by default it only removes the first occurrence of it. Yeah, only the first occurrence of it. There might be a keyword in remove that says remove all occurrences. That's something that you can dig into the documentation for. Or if you have an IDE, it will autocomplete it for you.
Nice, thank you.
So remove by index, remove by value. Oh, and if you try to remove something that's not in there, like we remove 2, returns a value error. Same thing. Let's say I didn't like my score. I only on the scores, I only got a 50. I want to remove that. I can also do del scores and give it the key, which is Mike. Check scores. No one knows that I got a failing grade.
Nice.
All right. Let's see. Oh, let's talk some basic addition. We kind of flew through our basic types. Let's do some basic addition. So I showed this off before. Basic addition. All of your standard symbols are supported. This is not multiply because x is a string, or it could be a variable, or well, in this case, it would be interpreted as a variable. Multiply is the asterisk. Let's actually get a better thing in there. And divide is our backslash. Note, Python 2, sorry, I'm going to keep looking over here whenever I say Python 2. There was a breaking change in Python 2 to Python 3. In Python 2, this 2 divided by 3 would not give you a float, it would give you the floor to the next index, or the next integer. So that would actually give you 0. But in Python 3, it acts like normal. If the result is not an integer, it turns it into a float. So if I do 6 divided by 3, actually, no, everything is a float. When you divide anything is a float. Again, always learn new things when I come back to basic level. There's another thing in programming languages, if you're not familiar with it. This is called Modulo. It is a shorthand for getting the remainder of a division. So 6 divided by 3 divides evenly, so our remainder is 0. So 6 mod 3 equals 0. However, if we have 5 mod 3, gives us 2 remainder, 4, so on and so forth. If you just want to have an is-odd function, all you'd have to do is my number mod 2. If it returns 0, then it's even. If it returns 1, it's true. In fact, let me introduce a new concept. Oh, actually, before we do that, last basic operator is exponents. So 3 raised to the power of 3 is 27. A lot of other languages will have a POW function. Python, you just double up on your asterisk. And that is all of the basic mathematical functions.
They didn't use the caret at all?
No caret.
I didn't think caret meant 0. I didn't read the power of 3 with the caret meant 0.
I got 1.
I forget what the caret operator is in Python. I would have to do research. I was actually wondering if you could even use a caret in Python. I'm sure it does something. Let's if it's not illegal, then it does something. Let's learn together. Could be a good point. I tend not to work with bitwise operators, so could be. Oh, caret.
That's how you spell carrot.
Nom nom.
Oh. X or A.
It is an X. It is indeed. All right.
Which means that it results to true if one and only one of the operands evaluates to true.
That's good to know.
But more importantly, carrot is C-A-R-A-T.
I've been doing Python for 6 years. I've been doing Python for 6 years, and I still learn new basic things. You never stop.
If I put spaces on either side of the caret, I get an integer comes back. But I don't know.
Yeah.
And it's not 0 or 1. Like 3 space caret 4 space 3 space caret space 4 would be 7. 3 space caret space 7 would be 4. I don't know what it is.
I don't know either. I just learned that this exists. All right. Anyway, let's get back into it. So basic mathematical operations: plus, minus, times, equals, mod, and raised to the power exponent. Oh, and if you need more than that, there is a math function, or there's a math library, import math. That's how you get pi out, things like that. But we will get to that not in this session. Let's talk a little bit about Booleans. So the lovely thing about Booleans is they are either true or false, 0 or 1, or I guess true and false, 1 and 0. Very easy. However, in Python, whereas we had single equal sign does variable assignment, double equals says are the values of these two things equal? Now this is obviously false because X is a list and is not equal to 1. So you can compare different classes. It's really just looking at it's saying are the values inherently the same, not are the objects the same. So we can do 1 equals 1, it returns true, same value. A equals B, or string A equals string B is not true, returns false. However, string A is not equal to string B, returns true. So double equals is are these two values the same? Exclamation sign equals are these values not the same?
Can you put X parentheses 2 equal 1?
X parentheses or bracket? So it whenever it sees an expression, it will evaluate both sides to until it has values that it can compare. Just give you an idea of what happened there. If we go back to X is 2, the third item in our integer list has a value of 1, so it compared value 1, is it equal to value 1, which it is, so it returned true.
Which means that you don't need if, or you still need it.
We'll get to that in a second. Building up to it. So, is equals, is not equals. We also have Is 1 greater than 5? No, it's not. Is it less than 5? True. Is 1 greater than or equal to 5? False. Less than or equal to 5? True. So, basic comparison operators. We can also do this with strings. So what do you think will happen if I do that? Is string A greater than or equal to string B?
Is that false?
That is true. Or your answer is true. Yeah. So just like with actual values, strings can be sorted in alphabetical order, and just think of it like putting it in a list. A comes before B, therefore A is less than B when sorting strings.
I don't want to, well, I do want to complicate things.
Go ahead.
You said Boolean is true or false, and you kind of almost said 1 and 0. Is there ever a time when the true and false translates to 1 and 0?
Well, in the deep in the bowels of the computer, where everything is 1s and 0s, a Boolean true is 1 and a Boolean false is 0.
I mean, in my code, would I ever be able to interchange the two?
I'm gonna blow your mind. So here's the fun thing. We're gonna introduce our if statement, and in Python, if is if. So if true, and just for the sake of doing things here in proper notation, I added 2 spaces in front. So let me go ahead and print my if true, print is true. Our if statement evaluated to true, so it went ahead and printed is true. Now, this is where we are finally working with the fact that Python deals with white space. White space is significant, and because of that, it frees up some characters for us to use elsewhere, like our curly braces that a lot of other languages use. And it also enforces code readability. Because in a lot of other languages, indenting your code, adding spaces to make things look nice when you're doing loops, and that's all optional. If you want to, you can put everything on a single line like a minified JavaScript library. In Python, you can't do that. So if you're a beginner, it ingrains good coding practice into you. And if you're an advanced programmer, it means that you will be pulling your hair out because someone is indenting their file with 2 spaces instead of 4, or with tabs, or vice versa.
Can you stop?
When I click tab, it puts 4 spaces. But that's completely up to taste, and if anyone doesn't do it the way you do, they're wrong. As it goes. So let's go back to our print statement for the sake of explanation. If false, it does nothing, because in order to get into the indented section of our if statement, it must evaluate to true. So, what is true? Here's the fun thing. Something that makes Python unique is that everything in Python evaluates to a Boolean in some way. And if you get a good grasp of what values, or what how the collections and strings and other things, how they evaluate to Boolean to a true/false value, can make your code very succinct and, quote, Pythonic. So
Just for the way of tormenting, if you put if true, print is true, is it going to work?
So if just on a single line?
The same that you did in the previous one.
So just that, and then do
Yes. So it resets, not because the previous
Yeah,
command
this is
failed.
completely independent bits of code. We're not working with variables in
It
this.
left it false. So
Yeah,
it
it's,
resets every time it resets.
each if statement doesn't depend on the previous if statement. So let's go to, speaking of ones and zeros, what do you think will happen here?
I think it's gonna print.
It prints. Oh, and for this, while we're just doing this, I'm just going to do this. In Python, if you have a loop that if you have an intended code block that only has one line in it, you technically can do this. I used to do, but it's not good form. But for the sake of making these faster, we're just going to do it like this. So 1 is true, and if we give it a 0, false. What if we give it a -1?
True.
It's true. For integers, any value that is not 0 is true, and a value of 0 is false. That's also true with floats. Now, what about strings? So, what do you think that would do? It's true. Before we get to the other thing, what do you think? Well, actually, and I need to do this. That should give you a clue. What do you think that would do?
No.
Surprise!
Yeah.
So,
Question.
question.
Sorry, did you say that it's not good practice to use an inline if?
It's not good coding style to use this single line if statement like we are. But I'm just doing it because it makes it go really fast. So.
I had to because when I hit return after false, it said invalid. It wouldn't let me do anything. It wouldn't let me continue the line.
Just click enter a couple times. Or you should just have to click enter a couple times. So
If you take out the quotes, good, not printed.
So, if we
Take out the quotes and false, that is going to print. But what if you put if bool parentheses false, not quotes?
no parentheses, bool, like that.
Yes.
It's already a Boolean value. False is already a Boolean, so it's just casting it to itself. But here's a little trick when it comes to the if statement. This bool, casting things to a bool, is redundant because it automatically does that. So just kind of getting our string back here. Empty string is false. Empty lists are false. Empty dictionaries are false.
So they all end at 0.
You can think of it, anything with nothing in it evaluates as false. If it's a collection, like a string, a list, a dictionary, and a lot of other types that contain values like that. Yeah. So we don't have to cast anything. We don't have to cast things to a bool when we put them in an if statement. It automatically does that. Now, we already saw before that doing variable comparison using double equals or using not equals evaluates to a Boolean. We can do things like if 1 is greater than 5, print true. It doesn't. It evaluates to false. So we don't print anything. Now let's say I'm going to overwrite my x here. And we're just going to turn these into variables. Same thing. Go back up to my line here. We can now compare different variables. X and y. X is 1, y is 5. Evaluates to false. But now we're dealing with things that are not embedded values.
So in PHP, there are a lot of helper functions that evaluate to a Boolean. So you could say is in array or is a number or something like that. I know Python has the same thing. PHP often takes the shortcut of evaluating down and returning either to evaluate to a Boolean object in these instances, or is it at some level using a 1 or 0?
In Python itself, it evaluates to a Boolean type. Dev note: the basic C language, which is what Python is a wrapper around, does not actually have a Boolean type. It has an int2, which just means if you're not familiar with int with a number after it, it just means how many bits, how many slots for a 1 or 0 am I physically allocating to this value. So an int2 means that it can either be a 0 or a 1, which in practice is a Boolean true or false. So a little behind the scenes. All right. Oh, and just to show you that there are other ways, there are multiple ways to do things. Let me actually overwrite my x value again. Let's get our happy list of integers back in there. Do len of x, that gives us 4. Now, if I do bool of x, it's true because it's a non-empty list. If I just want to, instead of wrapping it or casting it to a bool, you can also do is empty, or I might just be lying to myself. Let's use a dir and see. Append, clear, copy count, extend, index, insert, pop, remove, reverse sort. No, there is not. So, bool, if it evaluates, if we wanted to get is empty, I'm going to introduce another basic operator. We can do not bool x. Not negates the Boolean value that comes after it. So in fact, I can just do not x, and it automatically assumes that I want to evaluate it to a Boolean, does so, and then negates it. We can also put this in our if statement. So either go ahead and change this to is x less than y, which is, oh, I changed it back to a list. So, let me go back to here. I'm just, for the sake of just making this work, I'm going to change this back to 1 and 5. 1 is, in fact, less than 5. However, I can, this statement inside the parentheses evaluates to a Boolean. So even without the parentheses, I can just negate whatever that value is, and it doesn't do anything.
So it'll perform the less than first, and then it'll do the not, and notice not to do the not on the 1.
Exactly. And it can get pretty complicated, but just know that if there's only one expression, anything that comes after the not will be evaluated before, because not needs to have something turned into a Boolean before it can negate it. Continuing with our if statement, there's just 2 things that I want to add into this. We already looked at equals, not equals, greater than, less than, greater than or equal to, less than or equal to, and our not negation. We can also do if true and. Other languages will have double ampersands. Python, we just use and. Both of those must be true. If one or both of them is not true, then the entire thing evaluates to false. What do you think would happen if we do that? True and not true.
False.
Other one turns into false, does nothing. We can also say true and not false, turns into true. And if we need to get, or actually, let me continue on to or. Other languages will have these as double vertical bars. Python, we just use or. So if true or false, if either one of these evaluates to true, then the expression evaluates to true. But if not true or false, both of them are false, the entire expression is false. Now with not, when we're using or and not, all these different things, they respect order of operations. Anything that you put inside of parentheses will be evaluated before things outside of parentheses. So in this case, true or false gets evaluated to true, which then gets negated by not, which means the entire thing is false. And same thing if we put in and, it will respect order of operations applies to everything in code, just like it applies to math in elementary school. All right, quick break before we go on. Next thing is going to be a for loop, but we have 30 minutes left. I would love to get a for loop going and then create a simple Python script, Python file that everyone can run. Does that sound good? Any questions before we continue?
Woo!
I'll take woos. This is a lot of information. I understand. I will have a link or two at the very end that everyone can go to afterwards. Two very different styles, so hopefully it will mesh with at least most of you in here. And on there, don't think I forgot about you. So we looked at if, Boolean operations, basic types. We looked at lists and dictionaries. Let me just quickly introduce the concept of a while loop. It's really simple when you think about it. A while loop is while some Boolean operation do a thing. I'm not going to press enter. Actually, I will press enter, and it will eventually give me an error saying that it's an infinite loop inside of my interpreter, and I will probably have to Control-C if it keeps going on forever. Basically, this just says, while true, keep doing a thing. It will keep doing a thing. It is keeping doing a thing, and I'm just going to manually do Control-C to get out of it. Now, where in the world would you actually want to use a while loop? You don't want to just do while true. Actually, sometimes you do want to do while true. That you can consider that being a can constantly keep running my web server. An example where you might just want to do while true, and then maybe something inside of it will tell it to stop. What we can do is say, let's say x equals 0. And while x is less than 10, we are going to print the value of x, and then we are going to do our x plus equals 1, and it should print x, the value of x that starts at 1 and goes all the way up to 10, and then quits our while loop. Actually, it starts at 0, then goes up to 9. Got my values mixed. So it printed. Every time that it gets to the bottom of the indented code block, it goes back to the top, checks to see if our Boolean condition is still valid. It still evaluates to true. If so, run it again. If not, continue on with our code. Now we're starting to get into multi-line code blocks here. So really, that is as simple as while loops get. They will continue doing something. Now, let's say I had my, let me reset my value of x to 0. I'm actually going to do while true. This was not so good last time. It just kept on running. However, I'm going to say if, we're using an if statement here, if the value of x is greater than or equal to 10, we're actually going to break out of our loop. Else is if we don't go into our block, go into our else. We'll print x and then increment. So even though we have a while true, this does exactly the same thing. It prints the same thing to our code. And in fact, I just introduced else. I didn't even have to use it, technically, because the only time that we actually go into our if statement there is when we break out of the loop. And our else code wouldn't run anyway. So I can just get all this code back. And just get our break. And then without even doing our else statement, I can still get the other code in there. Same thing. How does it know if it's true and false? So whenever it gets down, when it first gets to the line that has the while loop, it checks to see if the value is true or false, to see if it will even go into the while loop. And then it runs all the code inside of the while loop. When it gets to the bottom, it checks the value again. If it's true, it continues on with another loop until whatever expression we gave it evaluates to false. In this case, we said while true, which will always evaluate to true. So it's an infinite list, or it's an infinite loop, which meant that in order to get out of it on a code basis, we had to introduce a break.
I'm having indentation problems. It didn't like the indentation that it defaulted to, and I'm trying to do the 4 spaces.
You gotta hit break twice.
As
The default didn't work, and I'm trying to force 4 spaces. And it's
So the bit of the code that we have up there, inside the while, I just, for the if, print, and x plus equals 1, I just had 2 spaces. Yeah. Yeah, you go in there, you have to add your spaces in so it knows that it's inside the block because now white space is important. And it also really likes consistent spacing. It doesn't have to be as long as each of the code blocks are of the same indentation level. But for the sake of readability, it is always a good idea to say each indentation level should be of the exact same amount. So if you're using 4 spaces, one block in should always be 4 spaces, 2 blocks in should always be 8 spaces, so on. We'll get to that in a second when we open up a Python file. Just to quickly introduce a for loop, I'm going to write over my x again to bring up our lovely little 1, 2, 3, 4 list. We're going to do for I in x print I. So a for in loop. So we say for some variable name that I am creating here that is going to contain the value that we are currently at of our list X. Inside each loop, and for the sake of also doing the indentation, every time that we go in, that we go inside our for loop, it increments the value from X that gets assigned to our variable I, so that we can. The nice thing about Python is that it almost always reads as though you would expect it to in English. So I'm just using I. I actually prefer to use notation like for item in X. Oh. Print out the item. It's very readable. Typically when you see I, it just means index, like the index of it.
Why are printable fours?
So our for I in X, I is still in scope. So I is in scope, item is in scope. They still exist outside of the for loop. Typically you won't see people access things outside of for loops like that, but you can.
Separate program or bad program?
Separate program?
Is it a good way of programming, or is
You-
it a bad way of programming using values that were set up but are not clearly defined?
It's typically bad programming. You almost will never see people access the well, in this case, item outside of the for loop that it was intended to be used in, even though you can. I think other languages don't allow you to do it.
Yes, many.
They do.
Many languages allow you to use the value that was
Okay.
remained. Then the problem is whenever you are looking for the value, it's really hard to find.
All right. Let's go to our dictionary.
So you have while, you have for, do you have until?
Say that again.
You have while,
Mm-hmm.
you have for.
For.
Do you have until?
No. Yeah. Until is not a command in Python. Yeah, because everything is evaluated at the top of the list, whereas other languages you can either prepend or postpend your incrementer. Everything is evaluated at the top.
So that's my question.
Okay. So let's do our for loop on our scores. Now because a list has only, you can only have a single value per index in a list, we only need for I in list. For dictionaries, because we have keys and values, we actually, this might take me a second to get right. Let me just double check. Okay, no. So what about just, okay. Okay. Oh yeah, that's right. So we just get 4 key in scores, and we iterate through the keys in our dictionary. So if we just want, so this 4k in scores print k, we just printed out all of the keys in our list. And if we wanted to print out the scores, we can call scores k for each key in the list. There's their scores. If we wanted to get, well, actually, let's go ahead and do this. So I'm going to keep print k. That is so that 4K in scores is functionally identical to scores.keys. And if we just wanted the values out without caring about keeping the getting the key values, we can get our values out of it. This is where those generator objects come into play. If you don't actually need to treat them as a list, if you're just using them in something like a for loop, you won't even know, and it's actually much faster without you really even having to worry about it.
Instead of K, would you say keys or is it always?
Oh, it's whatever I want it to be. In this case, I would actually do something more like for item in values or for value in values.
So I'm going to choose the first item in.
Yeah, you can just name it whatever you want because you are assigning a new variable.
Okay.
For some reason, when I do that, it's giving me the name and the score. I think I might have made my list wrong. It's not separating out into two separate things.
That actually is.
Well, you actually have a list.
Oh yeah, you have a list.
First was a dictionary, then I changed it.
Oh yeah, so just to show everyone what's on his screen, remember that Python you can have multiple things. So without retyping all the names, he has something like this, which is just a list with mixed string and integer values. Whereas this is a dictionary, we're using colons to separate keys and its associated value. Now let's say we wanted both items. The other thing we can get is actually items. And because, actually, for the sake of clarity, I'm going to call this pair. So when we call items, it is actually going to return what is called a tuple. A tuple is a list that cannot be changed. You can access the values in the list. You cannot add any more values into the tuple. You should be able to change the value of the items in the tuple, but you cannot remove or add anything to it. And it's really just an optimization thing. But if we do for pair in scores.items, print pair, it's going to print our tuple where the first thing is our key and the second thing is our score. And we can take advantage of that in Python because we can break tuples out into different things. So I'm just going to say key and value. I am now breaking up my tuple that has length of 2 into 2 different variables, key and value. And I'm going to print, I'm going to quickly introduce a quick little concept. This is string formatting. Those curly braces inside of the string are special little signifiers to say that at the first time that that the string contains one of these little curly braces, go ahead and put the same index. So the first time it comes up, it will insert the value of key, and the second time it finds it, it will insert the value of value. So a lot going on. Charlie scored 80, Andrew scored 85, Sadie scored 100. Yeah, so this is a print statement that is printing a string that we are inserting values into. This is functionally inside of these curly braces. We can actually give it indexes. This is functionally identical because the first one was purely based on location or position, and this one we are explicitly declaring the index, the value that we are feeding into our format function should go here. So that will print out the same. What do you think will happen if I put 0 in this last one and put 1 in this one? Yep. So somehow 100 scored Sadie. But we can do that. We have 13 minutes left. Let's create. So, however you want to make a file, you can open up your text editor and then just name it when we save the file. I just did a little Cody thing using my terminal to actually create a new Python file on my desktop. But however you can create files, go ahead and open up a new one. So I have my lovely little VS Code text editor here. And I'm actually, for people who are interested, I have installed this lovely Python extension. It is pretty much everything included. If you just search Python, it is the top one, and it is wonderful. But myfile.py, Python files, the file extension is .py. Simple as that. And then you can name it whatever you want. And let's just start typing in some stuff. I'm going to introduce you guys to another basic function called input. And input takes a prompt, give me a number, and we're going to put this on, we're just going to say X. I'm actually going to copy this down, and we're going to set this to value, or to variable Y. Give me another number. And then we can print, let's just say X plus Y. So what this is going to do when we run this file, it is going to prompt the user for input twice. It's going to ask us for a number. And the input should evaluate the number, well, a number that we give it to be a number. And then it's going to do that twice. And then print out those two numbers added together. I'll give everyone a little bit of time to catch up.
Trying to save my file as a Python file, but it didn't.
So there's nothing inherently special about a Python file. It's just a regular text file. So you can open it up in Notepad if you want, and then you can just, when you go to your file browser, you can just change the .txt to .py.
Oh, okay.
Yeah. I prefer to use a text editor because code is just text. That's all it is.
It's sublime, I don't know if it's. Okay.
Partially for Python, but mostly for me.
Walk around and see.
Yeah.
Oh.
You're running this also? Yeah. Oh, no, yeah, I was just wondering that you said like, oh, so I know you guys will be running this directly.
Probably
I would just say, yeah, I got this.
Because the same thing.
Anything that will just pop it.
I'm
If you run it directly from the terminal,
Right, okay.
I know that, dictionaries aren't ordered.
Yeah, this is a
But why is it just like totally
Because when it goes to store your dictionary, it will put it in random, like, it's not ordered, but it will literally reshuffle things to get it to fit the best way. Python does,
This is the whole idea about
let me see, just
So
before I.
basically, if I follow.
I mean, you guys did it a couple times, but it was the same thing.
Then I'll just go ahead and fix it.
You know, you already know.
Yes,
You
you
did
guys
that all
ended up
the
hearing
time.
it the same
Seven,
thing.
right, next to like 5 plus 7 equals
So-
12.
Python is a higher level language than C, in that it optimizes how it's storing things. So it's not, in C you have to work with things called pointers, in which you're pointing to a specific byte in memory as to whether or not that list is, where it is and what that information is. Python takes care of that for you, so when all of that, routing is happening, it's just arbitrarily being like, okay, you go there, you go there, and you go there, and then whatever gets returned first
So why
is
is
just
it concatenated
the closest
instead of
to
actually
the
adding?
I'm about to tell people that.
Yeah, I just
Links to string instead of an int.
So, a lot of you are looking good. Some of you have come up with some interesting observations about this. So if we go ahead and run this file, by the way, if you're using the Python idle, you actually will want to add another little blank input. Otherwise, it's just going to close your execution terminal. If you're running it from a regular terminal, you're not going to have that problem. Just know that. So go ahead and save it. I'm actually going to pop up the integrated console on VS Code on here. And to run our Python files, if you used Python to open up your interactive prompt, all you need is Python. If you used Python 3, do Python 3. It won't hurt to use Python 3 either way, but whatever. And then we give it the name of our file, and most likely, let me actually get into CD my desktop. There we go. Tab completion works. So myfile.py. And if we run it, it should ask, give me a number. Let's give it 3. Give me another number, 4. Now if you remember, we told it to add these together. Why is it giving me 34?
It's just a string, not an int.
Input returns a string and does not evaluate anything. So you can add 2 strings together. Remember that we added 2 lists together earlier? Strings are just lists of characters. We can add them together. So it's just adding string 3 and string 4 to give a string 34. And in fact, if we go into, let's say we just call this, result equals x plus y. We can print x plus y, and we can also print the type of result. Let me actually go up here and change this to result. We save that. We run it again. 3, 4. Class of type string. So we need to instead cast them to integers in order for them to actually add the numbers together. And if we do that, we give 3 and 4 again. It turned them into integers before adding them together. So we get 7 whose type is int. Have a question in the back? Okay.
How do you pull up what's there or like this?
Oh, so VS Code is control tilde. And let's see. Now, what do you think would happen if we run this and I give it anything that's not a number? Do you think that it will take 1.5?
No, because you called an integer, it will just make it 1.
Now, what well, so I'm just going to give it a float. Well, what's essentially a float, and what is an int? Invalid literal. We cannot, even though we try casting it to an int, if we don't give it a string that is in fact an int value, it will fail to cast it to a string, raise an error, and we can't continue on with our code. So, what can we do? Maybe add an if statement? Sorry, okay.
Import math function.
We don't need any kind of special math here. We can use a string function to test if it is a digit or not. So, we have x and y. We can do if x dot is digit and y dot is digit. And I'm just highlighting this and then pressing tab to indent all of it. So this dot is digit is a class function that takes no arguments and just checks to see if all of the characters in the string are numbers, digits. If both of them are, our if statement evaluates to true, and we continue with our function as normal. And to give that a test, we can do 3 and 4 again. Everything works. They both contain only digits. Here, a decimal is not a digit, and so it doesn't do anything. Both of them were not characters that contained only numbers, so it evaluated to false and didn't do anything. Now, let's say we wanted to add a message. We can do our else and do print, say, invalid input. So our else statement will run only if we don't go into our our actual if code block. So we can do our 1 and 5 again to invalid input. There's only one other type of if entry block. A lot of other, what I'm about to type is not it. Other languages will do something like else if. Python is just elif. So elif, let's do elif x dot is digit. That means that y was what evaluated to false, so we can do print y is not a number. Oh, wrong one. My file, so let's give this one a valid one. We'll change this to 1.5. 1.5 is not a number. Technically it's a number, it's just not an integer. Yeah.
I keep getting the word none popping up on my screen when I run it. It just says none. It gives me all the answers, but it also adds the word none. I didn't ask anything about that.
Let's see. None.
Yeah, but that's it right there.
Oh, so get rid of this print statement right here. Sorry, print actually does return none. It just prints things out to the console.
So just delete it.
But if we could also just do this. If x is digit, xy is digit. Then we do that. We can add an else down here. The only possible way that we could get into this else is if x was a valid digit and y wasn't. So actually, this print y is not a number would go up here. And the only reason why we get into this else block here actually, let me just bring this up, is if x is not a number. Am I blowing any minds at this point?
Could it be easier if you suppress the second if?
Yeah, so if not y dot is digit?
You're saying if not x digit, or even if x digit.
It would just move where this will get placed. So if not y dot is digit, this will get moved in here, and this will get moved to the else, but it's not quite as clear.
So I'm thinking if not x digit, then you said x is not a number. If
So
not y digit,
you can think of this if we just remove all of that code.
right?
You know, if x is a digit, do something else, then it's not a number.
Well, you're testing just the first one.
Yeah, we're testing just the first one, but if this first one doesn't pass, we don't even care about what the value of y is. We just immediately go down and say you cannot go any further. If statements are called logic gates for a reason. This one just happens to be a Boolean logic gate, and it really, if the expression does not evaluate to true, you don't get to go past the gate into the next step. As simple as that.
How do you run that file again on the terminal?
So in the terminal, we call up Python, and then we give it the name of a Python file. You would have to be in this. You would have to be in the same directory if you're calling from terminal PowerShell.
You don't have to be inside Python.
You don't have to be inside Python. Yeah, I'm just in my folder here.
Right.
Airflow. I'm in my desktop folder right now. And you can actually see my current folder contains my file.py when I list all the contents, which means I can do Python and then do tab completion. And then we just run it. So give me a number. I can give it 1 and then 2. Everything works. I can run it again. I can give it 1.5 and 2. 1.5 is not a number, or it's not a digit. And it didn't even care what the value of 2 was because we already knew that one of them was false. Now, then if we give it 2 and let me just say none, that's just going to be a string none. It's not actually the value, the none type. But, oh, actually, let me Control C out of that. We want to give x a good value, and we'll just give y not a bad value. Since it didn't pass, it passed the first if statement, but it didn't pass the second if statement, and so we printed out y is not a number. So it is 9:07, and we addressed running the interactive prompt. We created and ran a Python file, went through the basic file, the basic object, variable types, variable assignment, worked a little bit with strings, lists, and dictionaries, and then did some Boolean fun, some Boolean logic fun, if statements, while loops, and for loops. That's a lot in 2 hours. If this probably went a little too fast for some people, don't worry. We had the live stream. The live stream is recorded. You can always go back and watch it in case we went a little too fast or skipped over something. I would also point everyone to two sites. The first one I want to pull up is a site called learnxandYminutes.com. I absolutely love this little site. It has tons of different languages. I have no idea what chicken is, but I'm now hungry. CMake, CoffeeScript. If you want to learn about CSS, F#, you want to go back to Fortran, JavaScript, look at some JSON stuff. But we care about Python 3. And what this site does is it gives you the basics. And when I say basics, I'm not just talking about basics. I'm talking about 0 to even if you've been around for a while, you will learn something new in a file that runs as is. So everything inside of here, I can copy and paste into a Python file and it will run. So you have numbers. It shows you some basic math. Oh, we didn't get to this. This double division sign does integer division, which is what Python 2 used to do. So if you do 5 double divide 3 gives you 1. It just takes everything minus the remainder. So 7 divided by 3 is 2. It takes the floor down to the nearest end. There's our mod parentheses going through all. Here's our not, our and or, Boolean expressions. Oh, we didn't even get to is. Is actually does object comparison. So is it the same exact thing in space on disk? You won't use it a whole lot. You will use it a lot if you're trying to say if A is none, because that's what you're supposed to do there. Strings, adding strings. We got down more or less to this point here, which is already just slightly more than halfway down the entire file. That's a lot. Yes, I will put this URL and the next URL I am about to pull up. These will be comments on the meetup page. So learn X and Y minutes, Python 3. The other one I would like to pull up, if just looking at a bunch of text